Tonight's video is on section 3.2, the mean value theorem and Rolle's theorem. The homework from this is 1, 2, 13 through 19 odd, 23, 33, 34, and 37 through 45 odd. The mean value theorem and the Rolle's theorem are existence theorems. They're theorems to use to prove existence. Then after you have proved that it's existed, then you have to go find the answer. So let's start with mean value theorem, or MVT. If the function f is continuous on a closed interval from a to b, and if f is differentiable, or you can take the derivative on the open interval from a to b, then there exists a c in this open interval from a to b such that the first derivative at c is equal to the slope between points a and b. Let me show you a picture of that. Let me smooth that up just a little bit more. There we go. And so I have a graph and I have function f. And let's say there's a and b. So between a and b on the closed interval, it is clearly continuous. And on the open interval from a until b, it is differentiable. There is no sharp turns or no holes, no piecewise functions. So then, by the mean value theorem, there exists some c where in the open interval between a and b, that means I cannot include those endpoints, but anywhere in between, such that the first derivative at c, in other words, the slope of the tangent line at c to f, is equal to, well, remember what this is. This is y2 minus y1 over x2 minus x1. At points a and b on f, this is just slope, right? Slope f of b minus f of a over b minus a. So these slopes here are the same. So there's some c that exists. The Rolle's value theorem is just a very, very specific case of the mean value theorem. Rolle's theorem says, again, if f is continuous on this closed interval, and if f is differentiable on this open interval from a to b, then if f of a, the y, is equal to the y, it's going to produce a horizontal line, right? So I have some function f. Let's go ahead and let's show that while I'm finishing the Rolle's value theorem. That f of b equals f of a, that the y outputs from a and b are the same, the two y's are the same on f. Then what? Then there exists at least one c in this open interval such that the first derivative, or the slope of the tangent line at c, is equal to 0. Because if these two y's are the same at these two different x values, it's got to be a horizontal line. Both the y's are the same. So I'm saying that there's some c in between that when you take the first derivative, or the slope of it, it is also 0. In other words, these two are parallel and these two are parallel. Just this one can be any slope. Rolle's value theorem is very specific. If the y's are the same, then that means it's a horizontal line. Then there's some c in between in which the slope of the tangent line is also 0. So let's take a look and see how we might use this. In fact, let's look at a couple of graph examples. So if I have A and B, and A and B and A and B. So from A to B, it is clearly continuous on the closed interval, but on the open interval, it's not differentiable. So I cannot use mean value theorem or Rolle's theorem because it does not satisfy, and f is differentiable from a to b. That is not true because of this value right here. From this a to b, this is also true because I can draw a vertical line. So when I take my slope is undefined there. My slope is undefined. So I cannot use mean value theorem or Rolle's theorem for an existence. for this one here, from this interval from A to B on the open interval, it is not even continuous. So I cannot use mean value theorem or Rolle's theorem at all. It fails there. So algebraically, let's do a problem. So in 13 through, let's see, what was the homework again? 13 through 19 odd, we're going to use the Rolle's value theorem. So if f of a equals f of b, then there is the first derivative, or the slope of the tangent line at c is equal to 0. So let's take our function, f of x. It equals x minus 3 times the quantity x plus 1 quantity squared, from the closed interval from -1 to 3. And I kind of just denote that that's your a and b. So f is continuous. It is continuous. There's no x value I cannot use. So it is continuous. And it is differentiable. This is just a cubic. So there's no place where there's going to be any kind of a sharp turn. And there's going to be no vertical asymptote. Remember, a vertical asymptote you find by looking at the denominator. There is no denominator position here. So it is continuous and it is differentiable on the open interval. I may continue. I may use the mean value theorem and Rolle's theorem. So, if f of a equals f of b, let's go check that out. A and b is what? My two endpoints of my closed interval. So let's do f of -1. I'm going to evaluate that. Let's see what I get. Let's see, that's a -4. That's 0. -4 times 0, that's 0. So at x equaling -1, that is 0. Now we got to check out the b, f of b. I have to see if the if holds up. So I'm going to put in 3. 3 minus 3 is 0. 3 plus 1 is 4. So -1, 0, and 3, 0. So I sketched out myself a little graph. -1, 0, and 3, 0. So I can go ahead and I can use the Rolle's theorem so far because I do have this. Then there is some c in between that when I take the derivative is also going to be 0. Because in between these two, it's going to go above and beyond, or it's going to go down. So let's go ahead and let's take the first derivative to find my relative min or my relative max, because that's going to be my c value. So let's take the first derivative. So I went ahead and I took the first derivative of this function up here. I had to go ahead and use the product rule with the chain rule. Then, since I am going to set this equal to 0, I need to go ahead and factor out my x plus 1. I took out an x plus 1 out of both terms. I'm left with an x plus 1 plus 2 times x minus 3. We'll just multiply this all up, get a bunch of terms, x plus 1 plus 2x minus 6. So now I have my two factors, x plus 1 and 3x minus 5. I'm going to set that equal to 0 to find my critical numbers, to find my relative mins and maxes. So x equals -1 and 5/3. So I don't need to find out which is which is a relative min or which is a relative max. I do not care if it goes above or below. All I know is that these 2 points are equal and that slope is 0. There's some c in between, maybe it's down here, that also has a slope of 0. It's going to be at the max or at the min. So I have two possible relative mins or max, -1 or 5/3, except the c has to be inside of this open interval from -1 to 3. And I found -1. So -1 is not included in my open interval. So therefore, -1 is not included. It is only 5/3. That's only in that open interval. So c equals 5/3. Why? Because that's where my slope is 0. At what x? At 5/3, which happens to be my c. Let's try another one. This time it'll be the mean value theorem. So again, let's see in your homework, from 37 to 45 odd is going to ask you the same thing, but now using the mean value theorem, in which that slope can be anything. Rolle's has to be 0. So by the mean value theorem, that the derivative at C is equal to, which is the slope of the tangent line, to the slope from A to B. Remember, that's just y2 minus y1 over x2 minus x1. That's just the slope between A and B. So I'm going to take my function on the closed interval from -1 to 1. Just remind myself I'm going to call that A and B. So f is continuous. I can use all those x's between -1 and 1. In fact, I can use every x. Nowhere am I going to get undefined. And f is differentiable between -1 and 1. It's only not differentiable if I have a denominator. There is no denominator, so it exists everywhere. So let's go ahead and let's find all of these. What is my A and B? Again, my -1 and 1. So in fact, how about I stop here for a moment? I want to do f prime of C equals, let's see, B. So that's f of 1 minus f of -1 over 1 minus -1. Right? All I did was take my A and B and I filled it in. So that's what I'm going to go get. I'm going to go get f of -1 right now, and then I'm going to go get f of 1, and then fill this out. So f of -1. So I'm going to substitute in -1 and -1 and -1. And what do I get? 0. So my first order pair is -1, 0. Now let's go do the other endpoint, B. Right? Isn't that what I need? So f of 1. Put in 1 everywhere for x. So 1 squared, it's 1, minus 1, that's 0. 0 and a -2 is -2. -2 times 1 is -2. So this next order pair is 1, -2. See, look it, there it is. So what was f of 1? F of 1 was -2. Minus, what was f of -1? 0. 1 minus minus 1, which is really 1 plus 1, which is 2. So the slope, what does that say? That there's going to be the slope of the tangent line at C is going to be equal to -1. That's the slope. The slope is -1, right? So isn't that kind of like -1? Down 1 over 1, down 1 over 1. There's going to be some C, because the slope here is -1 between these two values. All right, let's sketch that out. 0, -1, and at 1, it's going to be -2. There it is. So there's going to be some C in between -1 and 1 in which the slope is the same. So I guess what I need to go do now is go take the first derivative. So here we go. First derivative, what I'm going to have to use. I went ahead and I used the product rule. I don't know why I did that. I should have just multiplied that in and then just took the derivative of each term, because I did it the hard way this time. So I went ahead and I used the long way product rule, which is okay. Get a whole bunch of terms, and that ends up being 3x squared minus 2x minus 2. So f prime of x equals this. Sorry for the mess. And again, I'm looking for a C where the slope is equal to -1, right? So I'm going to set this equal to -1. What x's, or in other words, what c's give me a slope of -1? And it has to be between the interval, open interval of -1 and 1. Let's go solve for this, but this is a quadratic. Whenever I solve a quadratic, I want 0 on one side. So let's scoot that -1 over by adding 1 to both sides. Now let's go ahead and in trying to factor it, I can't factor that. So I go ahead and I use the quadratic formula. -b plus or minus b squared minus 4 times a times c all over 2 times a. I go ahead and I proceed to clean that up. 2 over 6 plus or minus, let's see, what is that? That is going to be a positive 12 and a positive 4. There's a positive 16, so the square root of a positive 16 is 4, also over 6. So that's 1/3 plus or minus 2/3. So in other words, 1/3 plus 2/3 is 1. 1/3 minus 2/3 is a -1/3. But remember, I said it has to be in this open interval, and 1 is, you can't use 1. It's not a closed, it's an open interval. So I'm only allowed to use -1/3. So that is my C. That is my C. So the derivative at negative 1/3, the slope of it is going to be negative 1. Now, in a couple other homework problems, let's see. I think it's in 33 and 34. They ask you to go further, so I'm going to go ahead and do that with this problem. Even though in problem 40 they don't ask you to do it in these directions, I'm still going to practice this. They want me to find the equation of the secant line, or y1. The secant line, that's this one here. That's on y. That's my secant line. There's some curve. These 2 points are on f, right? That's my secant line. So I know the slope of it is negative 1. I'm going to pick a point on either one on the secant line. I'm going to pick negative 1, 0. So 0 is my y. Negative 1, oops, you can't quite see that, can you? And negative 1 is going to be my x. I'm going to clean that up. That's x plus 1. Well, that just cleans up to y. Negative 1 times x is negative x. That's really plus 1. So negative 1 times a positive 1 is a negative 1. So that's the equation of the secant line. In other words, I take my 2 points A and B. That's the equation of the secant line. Now, in fact, let's draw a little bit better picture. So here's like a secant line, but remember there's some C right there, that the slopes are the same. Where's that at? Right here. And so I've done y1. Here is y1. Okay, let's see if I can. That's the secant line. That's 2 points on my curve of f. That's the secant line. It cuts the curve in 2 places. There's some C right there on my graph of f where I take the first derivative and its slope are both the same. They're both negative 1. Now we're going to call this y2. I want the equation of the tangent line. That's this guy. So again, I'm going to do it in point slope form. y2, let's see, we said it was at negative 1/3 was the C value, or that x value there in between A and B. So I had to put negative 1/3 back into my f function right here, which is what I've done. So negative 1/3 times negative 1/3 quantity squared minus is a plus 1/3 minus 2. You clean up all that math and you get 14 over 27. I don't know why I didn't clean that up. That's really 2/3. I apologize, I didn't clean that up. I can see why. Oh, no, I should have cleaned it up. Well, let's see. How about I just do that right now? y2 minus 2/3 equals negative 1 x minus 1/3. Right? Negative. So that's y2 equals, that's negative x. That's really plus. So a negative 1 times a positive 1/3 is negative 1/3. And I'm going to add 2/3 over here. Again, this is the slope. This is the equation of the tangent line. Negative x. I'm going to add that together. That's the equation of the tangent line. At x equals c, which equals negative 1/3. That is that value inside of A to B. I have some value between A and B in which the slope of that secant line is equal to the slope of that tangent line. That's the mean value theorem. Thank you.